So yesterday, last class, previous class, different documents. Yes, yesterday's class, these basics were discussed. These basics reduction, like system software, application software. Next about OS discussed. Next front end, back end. Next language and packages. Next about low level language, high level language. These things were discussed. Yes. Today we should discuss about interpreter and compiler. Yes. Compilers and interpreters. Compilers and interpreters are used to convert from high level language to low level language. Yes, interpreter versus compiler. This topic we should discuss. Interpreter versus compiler. Interpreter versus compiler. Yes, interpreter and compiler. Interpreter and compiler. Interpreter and compiler. Both are to convert from high level language to binary code, but way of working is different. Okay, interpreter and compiler. Yes, interpreter and compiler. Interpreter, compiler. Yes, both are to. Yes, both are to convert. Both are to convert from high level language to binary codes. But the way it's working is different. Yes. See, both interpreter, compiler. See, both are to convert from high level language to binary codes. But the way of working is different. Let us see how interpreter working, how compiler is working. Interpreter versus compiler. Let us see about this step. Okay. Yes. Yes. First about interpreter. Yes, interpreter. 1 second. Yes, let us see about interpreter. First of all, interpreter. See, interpreter for this, let us take Python. Just I'm taking Python. How Python is working. So about test.py. Some Python script file. Yes. How interpreter is working. Let us see. How interpreter is working. Yes, interpreter versus compiler. Great topic. Interpreter versus compiler. Yes. Yes, how it's working. Let us see. First about interpreter. interpreter based language. Here I am taking Python. Just I am taking Python. Interpreter based language. I am taking Python. Python interpreter based language. Python. Yes. D drive. Python folder. Here is a test. Yes, some test script is available. Okay. See, Python application development means we can use, if it is Python application development, that case we can go for the PyCharm. Yes, we are using PyCharm for the Python applications. Okay. For easy understanding purpose, let us see Notepad. For easy understanding, we'll see Notepad now. Okay. Yes, D drive mnraf Python folder. D drive mnraf Python folder. Here Python script is available. Okay. So first, let us go to command prompt. Command prompt. Command prompt. Yes, D drive. Okay. Yes, D drive. Yes, D drive. Say DR. Yes, here they say mnraf Python. Mnraf Python. Yes, you guys can hear me. Hello. Can you hear me clearly? Any voice break getting? Can you hear me? Hello. Yeah. Thank you. Yeah. So mnraf Python. Mnraf Python folder. Mnraf Python folder. CD. Yes, here CD. Change of directory. CD means change of directory. mnraf Python. Mnraf Python. Yes. Yes. Here. Yes, here test.py file. It's a Python script file. Python script file. Yes, notepad. Notepad. Test.py. See, this is Python script. Yes, this script executing by the Python interpreter. It's a Python script. A equal 10, B equal 20, C equal to A plus B, C equal to A plus B, C addition equal to C. Next, subtraction and multiplication. Okay, program for this. Okay, program for addition, subtraction, and multiplication. Simply script, very simple script. Very simple script. Okay. Yes. Yes. Addition. Addition. Yes. Addition, subtraction, and multiplication. Addition, subtraction, and multiplication. Okay. Yes. Save and exit. Yes. Here, how it's working here. See. Here, the script directly you can submit it. No compilation, nothing here. Yes. Error checking, nothing required. Suppose if it is C program, yes, first of all checking for errors. But here nothing. Directly submission here. Directly submitting Python. That's it. Directly submitting script. Yes, no error checking, nothing. Directly execution, directly running script here. Directly getting output. Okay. Yes, here how script this Python script is working. Yes, how that interpreter is working. Let us see. How that interpreter is working. Let me explain clearly how that interpreter is working here. See interpreter suppose statements. Yes, suppose first statement, next statement, next statement, next statement. There are some statements. There are some statements. Sorry. There are some statements. Scripting statements. Yes, like that. A equal to 10, B equal to 20, C equal to A plus B like this. There's some statements, scripting statements. There's statements like top to bottom some statements. Okay. Yes, interpreter. Yes, Python, interpreter based language. Yes, how that interpreter is working. Let us see about interpreter, how it's working here. Okay. No, that Python should be installed in your system. Mr. Avinay, Python should be installed. Python should be installed. Python should be installed. And next one more path should be set. Path. I think path issue in your system. Path is not set. Okay, path. That path is Python should be installed and path should be there. See, path inherent variables, path edit. See here Python path. This path required. See users app data local programs Python 36. Without that path it won't work. That path required. Okay. Yeah. So you get this Python, a script submitted directly and executed. See here how interpreter is working here. See Python script interpreter how it's working here. See here interpreter. First of all, checking first statement. Checking first statement. Suppose first statement is correct. Suppose first statement is correct. No syntax error. Syntax is correct. Simply converts that first statement to binary code. The statement converts into binary code. The statement simply converts into binary zeros ones format. Okay, that statement given to processor. Okay, simply here. Yes, if the statement is correct here, statement correct, immediately converts into binary code. Yes, interpreter check for syntax. Syntax is correct, immediately converts into binary code. Yes, given to processor, generating output, immediately generating output here. Okay. Yes, next checking for next statements. Checking for next statements. Checking for next statements. Next statements. Suppose next statement also correct. Suppose next statement also correct. Next statement also correct. Next statement also correct. Simply just converts into binary code. Next statement also correct. Simply converts into binary code. Yes, given to processor. Just given to processor. So processor. Okay. Generating output. So here what's happening here? First line checking. Yes, correct. Converted, executed. Second line checking. Correct. Converted, executed here. So here it converts, executes, converts so line by line. See, next coming statement will be right or wrong. Okay. Interpreter never think about next coming statements. Interpreter never think about next statements. Interpreter never thinking about next statements. Next statements may be right or wrong. Next coming statements are right or wrong. Interpreter never think about next coming statements. Interpreter never think about next coming statements. Okay. If statement is correct, immediately converts into binary code, generating output. Next statement correct, converts into binary code, generating output. So like this line by line. Okay. Suppose something wrong here, something wrong, simply stops. Something wrong, simply stops. That's it here. Okay, any error comes, interpreter stops. Interpreter shows only one error. Interpreter shows only one error. Any error comes, simply interpreter stops. Any error, interpreter stops. That's it. Okay. Yes, 1 second. Yes. See here now. Program notepad. So yes, this program, whole program is correct. Whole program executed given output here. See this program. Nothing wrong here. Everything is correct. Yes, executed and generated output here. Now let us use some mistakes here. Some mistakes in this program. Suppose comma missing. Suppose here W quotation missing. Bracket missing. Something missing. Save. Okay. Now run it. Now run it here. Just run it. Yes. Where is error? 7th line. Once error comes, simply stops. It is not showing all the errors. No. Here interpreter won't show all the errors here. Any error comes, simply stops. Any error simply stops. Any error simply stops. So this error, 7th line error. Now let us correct that mistake here. 7th line error. Come on. Just after correction. Yes, save. And now run it here. Now 11th line error. So only one error. Interpreter shows only one error. Any error comes, simply interpreter stops. Any error comes, interpreter stops. Any error comes, interpreter stops. Any error comes, interpreter stops. Okay. So next error, correction of this error. Save. Save. Exit. So next, now submit again here. See, up arrow key. Using up arrow key, you can get the previous commands. It will maintain the history. Command prompt will maintain the history. It will maintain the history. So previous commands you can get it. So every time typing is not necessary. Up arrow key, up arrow key, up arrow key, up arrow key. You can get all the previous commands. Use up arrow key. To get previous commands, up arrow key. See up arrow key. This one it. See this. Now again 16th line error. So only one error at a time here. We can see only one error. Okay, shows only one error. Okay. Yes, next this one. Yes, save and exit. Okay. Yes, now here. On it. Yes, addition, subtraction. So this is working of interpreter. Interpreter working is like this. Interpreter working is like this. See, interpreter checks the first line. If first line is correct, immediately converts into binary codes and execute generating output here. See, next coming statements may be right or wrong. Interpreter never think about next coming statements. Interpreter never thinking about next statements. Interpreter never thinking about next statements. Next statement may be right or wrong. Never think about next statements here. Okay. If statement is correct, immediately converts into binary code, generating output. Checking for next also correct, converts into binary code, generating output here. Suppose something wrong, simply stops. Something wrong, simply stops. So this is a working of interpreter. This is interpreter working. Okay. Next compiler. Okay. Yes. Same thing. Let us take compiler. How compiler working here? Compiler. How compiler is working? Yes, compiler. Let us see about compiler here. Compiler. For this purpose, I'm taking some C program. Some test.c program. Some C program. Yes, how compile is working here? Same thing. If it is compiler, how it's working here? How it's working? See, compiler working is like this here. So first the compiler checks for first statement. Compiler working is like this. Compiler checking first statement. Suppose first statement is correct. Even correct, it won't convert into binary code. Checking for next statement. Next statement also correct. Even correct, it won't convert. What happens here? Compiler checks for the all statements from top to bottom, checking for syntax from top to bottom. Compiler checking for statements. No error, then checking for next statements. No error, checking for next statement. Suppose something wrong here. Yes, compiler shows that error yet third line. Error at third line. Yes, after that, checking for next statement. Next statement also correct. So checking for next time. So next like this. Next like this. Like this top to bottom. Compiler checks the whole program from top to bottom and shows all the errors. It shows all the errors. Suppose here error yet some line here. Okay. So next statement, checking for next statement. Okay. Checking for next like this. Top to bottom. Compiler checks the whole program from top to bottom and shows all the errors. Okay. See, in case of interpreter, what happens? Any error comes, starts. It won't go to next coming statements. Any error comes, stops here only. Interpreter stops here only. Any error is there, interpreter stops. But compiler is not like that. Compiler checking whole program from top to bottom. Compiler checking whole program from top to bottom. Okay. compiler checking whole program from top to bottom, compiler checking whole program from top to bottom and shows all the errors. It shows all the errors. Compiler shows all the errors in the program. Okay. Yes. Let me show that practically. Yes. C program. Let us take C program for this C program. Yeah. So this is C program. Yes, C program. Here the C program. Yes, main function. Yes, main. Yes, compile and run it. See this. First number 10, second number 20. So this is addition, subtraction, multiplication of two numbers. This is addition, subtraction, and multiplication of two numbers. So this program here, C program. See some math.cpp. Math.cpp. Yes. Here main function int a declared, b declared, c declared. Next enter first number, second number. Yes, reading this. Next addition. See addition, subtraction, multiplication, all this, right? Yes. No error. Okay. Now here let us do some mistakes here. Suppose here semicolon missing. Suppose here bracket missing. Suppose here comma missing. Okay. Suppose this bracket missing here. Suppose here printf this bracket missing. Suppose here semicolon missing. Okay. Suppose here this double quotation missing. Okay. Yes, get ch here bracket missing. Okay. Now saved. So name of the program math.cpp. Math.cpp. Now compilation. It's compiling. See compilation. Yes, enter compiling. See errors. Totally 9 errors. See that 9 errors. 9 errors. Press any key. See this. First error, next 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 like this. All the errors from top to bottom. See 14th line error. Yes, see this here. At the bottom you can see that line numbers. 14th line error. Yes, 18th line error, 22nd line error, 25th line error, 20. Yes, 9th line error, 36th line, 38th line, and 40th line. All these errors. Compiler shows all the errors from top to bottom. That's it here. Compiler checking whole program from top to bottom shows all the errors. Compiler shows all the errors. Now let us correct that all the mistakes here. Errors. Correction of all the errors. Here comma missing. So correction of all the errors from top to bottom. Let us correct it. Okay. Correction of errors. Printf. Here bracket missing. Okay. Yes. Next here. Here this is double quotation missing. Okay. Get ch. In get ch bracket missing. Okay. Now recompile again here. Yes. Two more errors here. Now here this error. So scanf here bracket missing. Okay. Yes, next here semicolon missing. Now compile. Yes, success. Okay. So compiles. Okay, after compilation, next run it. What happens? See here, checking for all the errors. Top to bottom, checking for all the errors here and shows all the errors. Compiler checks whole program from top to bottom. Compiler checks whole program from top to bottom. Whole program from top to bottom. Okay, whole program from top to bottom shows all the errors. Suppose no errors. Suppose correcting these errors. After correction of these errors, recompilation. Correction of all the errors. After correction, yes, if no errors, what happens here? After correction, yes, if no errors, what happens? Suppose everything is fine. If everything is fine, what happens? So compiler checks the whole program from top to bottom. Suppose if no errors here, then compiler opens another file. If no errors, then compiler opens one more file here. It opens one more file. After opening another file, this whole code means the C program code, all this code, Okay, that high level language, that English language, this whole code converts into binary format. This whole code converts into binary format, zeros ones format. That whole code converts into binary format like this, zeros ones format. Whole code converts into binary format. Okay, whole code converts into binary format. Just converts into binary format. All this code converts into binary format. Just converts into binary format. So convert into binary format. Write to another file. Write to another file. Okay. This result file. This result file is called as exe file. This result file is called as exe file. It generates one exe file. That exe file given to processor. Exe file given to processor. Now processor generates output here. Processor simply generating output. That's it here. So what happens here? Compiler checks the whole program from top to bottom. If no errors, generating one exe file. Just it generates exe file. It generates exe file. That exe file given to processor. Exe file given to processor. Exe file given to processor. So processor generating final output. That's it. Okay, let me show that exe file. See C program. Yes, C program. This is C math.cpp. CPP is C++. C++ and C both are same. So math.cpp. Math.cpp file here, backend. Let us go to backend. Yes, is a turbo C. Turbo C. C drive. TC. Yes, here bin. Instead of bin, see math.cpp. This is a file. Backend program. See this. Diagram to add, subtract, and multiply two numbers. See this. This is. Okay. Yes, I think it's not saved. 1 second. It's compiled but not saved. Save. Yes. See compile. Yes, success. Okay, fine. Yes, math.cpp. See math.cpp. See date and time of modification. 20th Jan. Today. Date and time of modification. Okay, 1 second. So this is some backup file. This file, let us delete all this. Here only one file math.cpp available. See, open this. See this. So this is the program. Okay, fine. Now see alt C. Now compilation. Compilation. Program compiles. After compilation, next C. Now I'm running this program. So when I'm running here, yes, before going to run it, first exe file creates. If I run this here, exe file creates and executes. Exe file, see backend. That exe file created just now. Yes, see 20th Jan, 6 o'clock, second minute. Application means exe file. Application is exe. That exe file. Exe file. See this math.exe file. .exe file created. That exe file contains binary code. Exe file contains binary code, system understandable language. Exe file contains binary code. It's a system understandable language. Exe file contains completely binary code. It's a system understandable language. See this. Now exe running now here. Then first number, second number, 20. Addition, subtraction, multiplication. That's it here. Okay. So what happens here? So compiler checks whole program from top to bottom. Compiler checks whole program from top to bottom here. If no errors, generating one exe file. Generates exe file like this. Generating exe file. That exe file given to processor. So processor taking that exe file, executes, finally generates output. That's it here. Now what's the difference observed here between interpreter and compiler? Interpreter and compiler. Yes, you guys, what's the difference you observed here? Interpreter and compiler. Yes, interpreter. See the document difference. Interpreter, compiler. What's the difference observed here? Yes, guys, come on. Interpreter line by line, that's okay. What is exactly difference observed here? Yes, you don't see anything here. Here, see here one box showing, right? Here only one box is there. In this expression, one more box. What is the second one? What is the second box? Why second box I showed here? Yes, come on, yes. Simple, very simple. What is this one? What is this is? This is generated, right? What is this generated here? exe file. See this exe file generated. exe file generated. Here it's exe file. exe file generated. It's exe file. Yes, in case of interpreter, any exe file? No exe file. In case of interpret, no exe file. Line by line executed, conversion then execution here. Conversion then execution, conversion then execution. But in case of compiler, what happens here? exe file created. This is a main difference. Main difference between interpreter and compiler, exe file. Compiler generates exe file. Compiler generates exe file. Compiler generates exe. Interpreter never generates exe. Okay. Now let us see that. Yes, differences. Interpreter versus compiler. Let me explain clearly all the differences. Yes, all the differences. See, interpreter. Yes, interpreter versus compiler. Interpreter versus compiler. What's the differences here? Interpreter versus compiler. See, interpreter. First one. Yes, interpreter checks the code line by line. Line by line. Compiler, whole program. Compiler, whole program from top to bottom. From top to bottom. From top to bottom. See, interpreter checks the code line by line. Interpreter checks the code. Interpreter checks the code line by line. Yes, compiler, whole program from top to bottom. Whole program from top to bottom. Okay. So interpreter checks the code. Interpreter checks the code line by line. Compiler, whole program from top to bottom. Okay, right? Yes, next. Next here, interpreter. Yes, it generates output. When come to output here, line by line output. It generates output line by line. Yes, line by line output, line by line. Yes, compiler. Yes, at a time. So in case of compiler generating one exe file, right? Compiler generates one exe file. That exe file executes directly. So at a time output here, at a time output here, at a time output, at a time output. Okay. Yes, next. See, in case of interpreter, yes, only one error, right? Interpreter shows only one error. If any error comes, interpreter stops. If any error comes, interpreter stops. That means it shows only one error. It shows only one error. It shows only one error. Interpreter shows only one error. Compiler, yes, all the errors. Shows all the errors from top to bottom. All the errors from top to bottom. From top to bottom. From top to bottom. All the errors from top to bottom. Okay. See, interpreter, it shows only one error. It shows only one error. Okay. But compiler, all the errors from top to bottom. Compiler shows all the errors. Compiler shows all the errors. Compiler shows all the errors from top to bottom. Top to bottom. Next, here main difference. Yes, interpreter. Yes, it does not. It does not generate exe file. It does not generate exe file. Compiler. Yes, it generates exe file. It generates exe file. It generates exe file. Okay. See, interpreter. It does not generate exe file. Yes, compiler generates exe file. So this is main difference. Main difference between interpreter and compiler is exe file. Is a difference here. Okay. Interpreter. It does not generate. It does not generate exe file. It does not generate exe file. Yes, compiler generates exe file. It generates exe file. Okay. Right. Next here. See, interpreter. Yes, it executes source code directly. 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 It executes source code directly here. See, interpreter based Python scripting. Python scripting. See, this is source code, right? Source code. This is source code. Yes, our program. So what are the program we are writing? That program is a source code. That program is a source code. Source code, right? Here, this source code executes directly here. Executing source code directly. No errors checking, nothing, no exe file, nothing here. Directly executing source code. Yes, interpreter based language. Directly the source code executes. Directly source code executes. Directly source code executes. Okay. So when come to compiler, if it is compiler exe file. See, compiler generates one exe file. Exe means executable file. Exe means executable file. It contains binary code. It's a system understandable language. Okay. Exe file. So exe file. See here, one exe file generated. So math.cpp for this math.exe file generated. It's a binary code file. It's a system understandable language. Okay. See here, this whole code, sub C program, the C program whole code. See C program. C program. See here, this is C program, right? Here, this is this English language, high level language. This high level language. This high level language completely converts into binary format. Binary code is system understandable language. System understandable language. This whole code converts into binary code right to another file. That is called as exe file. This is English C program English language. That C program English language. Okay. C program English language. That C program English language simply converts into binary format. Simply converts into binary format and write to some exe file. So this exe file contains binary code is system understandable language. C program, whole C program converts into binary format, system understandable language, and write to file. That is called as exe file. Exe file means executable file. It contains completely binary code. It's a system understandable language. It's a exe file, it's a binary code file. It's a system understandable language. I think it's clear, Mahesh. Mr. Mahesh, I think it's clear. Okay. Yes. Yes. So it's a binary code file, system understandable language. Okay. Fine. Yes. Now here. Okay. See, interpreter. It executes source code directly. Interpreter, it executes source code directly. It executes source code directly. Yes, when compile here, exe file, it generates exe file and executes exe file. Yes, executes, it executes exe file, it executes exe file, it executes exe file. Okay. So here, yes, in case of interpreter, it executes source code directly. It executes source code directly here. In case of compiler, yes, it executes exe file. It executes exe file. It executes exe file. Okay, fine. One second, let me have some water. Yes, next up. See here, interpreter based language. These are called scripting language. They are scripting languages. These are scripting languages. They are scripting languages. Okay, interpreter based. They are scripting languages. Okay, next, compiler based programming language. These are programming language. They are programming language. Compiler based is a programming language. Okay, so interpreter based is scripting language. Interpreter based are called as scripting language. These are scripting language. These are programming language. Scripting language examples. Scripting language examples here. Scripting languages examples. Python. Python is a scripting language. Python is a scripting language. HTML is a scripting language. Okay, JavaScript is a scripting language. JavaScript. JavaScript is not a Java. JavaScript is not a Java. JavaScript is not a Java. JavaScript is different. Java different here. JavaScript is not a Java. Okay. JavaScript using with HTML. Okay, for client side. Java is yes using at server side. JavaScript is a JavaScript is a browser understandable language. Java is a JVM understandable language. JavaScript is different. Java is different here. JavaScript is not a Java. So these are interpreter based language: Python, HTML, JavaScript. Okay, next. Yes, Linux shell scripting, Linux shell. Next, yes, PHP scripting here. Next, Perl scripting. They're all scripting language. Yes, programming language examples. Compiler based examples. C language. C language is an example of compiler based. Next, C++. Next, .NET C Sharp. So these are the examples of compiler based here. Programming language. Okay. See, interpreter based language. Interpreter based language here no exe file, right? Interpreter based language don't have exe file. So next difference, interpreter. See, interpreter. Yes, interpreter. Yes, interpreter based language. Interpreter based language don't have exe file. Don't have exe file. Interpreter based language don't have exe file. So here everything is exe file. So generating one exe file, then executing here. Here everything is an exe file here. So everything, yes, always executing exe file. Everything is an exe file. Everything is an exe file here. It's an exe file. So always working with exe file here. Right? So this is difference between interpreter and compiler. So interpreter checks the code line by line. Yes, compiler whole program top to bottom. So here interpreter line by line, but compiles all the lines at a time, checking all the lines here. Next, interpreter generating output, line by line output here. First line output, next line output, but compiler is not like this. In case of compiler here, yes, top to bottom checking all the errors, if no errors, creating exe file and running at a time. So at a time output here, at a time output here. Okay. Next, interpreter only one error. It shows only one error. It shows only one error. But compiler all the errors from top to bottom. Compiler shows all the errors. Compiler shows all the errors from top to bottom. Compiler, it shows all the errors from top to bottom. Okay. Interpreter, it does not generate exe file. Yes, interpreter don't have exe file. It does not generate. Yes, next compiler, it generates exe file. Compiler generates exe file. Okay. See, interpreter, it executes source code directly. Interpreter, it executes source code directly here, but compiler only exe file. Yes, interpreter directly source code executes, but in case of compiler, what happens here? One exe file generates. Just exe file generates. Okay, exe file generates. Okay, yes, exe file generates. Yes, exe file generates and executes here. See, interpreter. Yes, interpreter based language are called a scripting language. Interpreter based language are scripting language. Python is only scripting language. It's not a programming language. Python is not a programming language. Okay, scripting language open source. Okay, Python is open source language. Okay, suppose programming language, that is not a open source. Python just only scripting language, not a programming language. Python is not a programming language. Okay. See here, compiler based record as programming language. Okay. Yes. See, scripting means at any time that can be modified. Scripting means any time can be modified. Okay. Python script. See, Python. See, the script anytime can modify. Okay. Suppose if it is programming C language, suppose C programming exe file generates. That exe cannot modify. Yes, once exe file generated, we cannot modify. But Python script can be modified anytime. Anytime we can modify the Python script. It's open source. So scripting is open source. Okay. Yes. See this. Scripting. Scripting is an open source. Scripting is an open source. Scripting is an open source. Yes, anytime it can be modified. 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 Sorry. Anytime it can be modified. But compiler, yes, it's not an open source. Not an open source. Not an open source. Not an open source. Not an open source here. So once exe file created, once exe file generated. Yes, we cannot modify. We cannot modify. So this is difference. Okay. Yes, fine. Yes, here some doubt here. Some guys, you guys maybe some getting doubt. See this trainer, Mr. M.N. Rao. M.N. Rao is explaining all this very Java, but he's not talking about Java. He's talking about all these basics. Okay, very Java. Yes, he's not talking about Java. Very Java. Now let us see. Now Java comes under what? Is it interpreter based language or compiler based language? What is Java? Yes, anyone idea? So what is Java? Yes, let us see about Java. What is Java here? Java, about Java. Java. Yes, is it interpreter based language or yes? So what is Java? Is it interpreter based language or is it interpreter based language or compiler based? That is question. Now about Java. Yes, Java. Is it interpreter based language or compiler based language or both? That is a question here. 1 second. Yeah, Deepak, wait. Yes, we are discussing. EXE files for platform dependent or not, the topic we'll discuss. Okay. Yes, very good question. We'll discuss about EXE file independent of platform. Yes, EXE file we'll discuss. Okay. See about Java. Okay, EXE file dot class file differences. What is EXE file? How EXE file is working? Next, what is dot class file? How dot class file is working? The topic we'll discuss. EXE file dot class file differences. What is exactly EXE file? Is it OS dependent or not? Next, dot class. All the topics we'll discuss today. Okay. Yes. Now, what is Java? See, just let me explain about Java. I'll explain about Java, then you decide it. Okay. See, I'll explain about Java. You decide it. Just I'll explain about what is Java exactly. I'll explain. You decide. Compiler or interpreter. Just you decide it here. Okay. Yes. Let us see about Java. How Java is working. Yes. Let us see about Java. Yes. See. Except Java. In other languages. Except Java. In other languages. What happens here? Except Java. Okay. See, except Java in other languages. What happens here? Suppose C program or Python scripting, something like this. The source code converts into binary code. Source code converts to binary code. Okay. Except Java in other languages, source code converts to binary code. The binary code given to processor, and finally generating output. This is other language except Java. In other languages, C language or Python or C++, any other language. Next in Java. Yes, if it is Java, what happens here? In Java, what happens here? Java, first of all, source code. Java, first of all, source code converts into bytecode. Source code converts into bytecode. Bytecode. What is bytecode? We'll discuss. I will explain. Okay, source code converts into bytecode. Bytecode converted into binary code. Bytecode converted into binary code here. Binary code. That binary code given to processor. Binary code given to processor. So processor taking binary code generating outputs into that here. Okay. In Java, what is happening here? First of all, source code converts into bytecode. That bytecode converted into binary code. Binary code given to processor. In Java, yes, some intermediate code introduced here. Intermediate code, bytecode. In Java, bytecode introduced here. So why bytecode introduced in Java? To make the Java as independent of platform. Here the topic we'll discuss. Okay. So how Java made us independent of platform, we'll discuss. Wait. we'll discuss. Yes, here bytecode introduced in Java. Bytecode introduced in Java. Bytecode introduced. Reason to make the Java as independent platform. To make the Java as independent platform. Okay. See, source code converts into bytecode here. The bytecode converts into binary code and given to processor, generating output. See, except that with other language, source code to binary code. Source code to binary code by the either compiler or interpreter. Either compiler or only one thing. So either compiler or interpreter. Either compiler or interpreter. Either compiler or interpreter converts source code to binary code. Source code to binary code are generating output. But in case of Java, what happens here? Source code to bytecode. Okay, this part by the compiler. Java compiler is by the compiler. This is by the compiler. This part by the compiler. So compiler checking for all the errors. Compiler checking for the all the errors in Java program here. If no errors, generating a bytecode file here. So source code to bytecode by the compiler. Compiler checking for all the errors. Okay, if no errors, generating bytecode. Okay, yes. Next here, see bytecode to binary codes. Bytecode to binary codes. Bytecode to binary codes. Bytecode to binary code by the interpreter. By the interpreter. This part is by the Java interpreter. Okay. Source code means whatever the program we are writing, that is called as source codes. See, whatever the program we are writing, our program called as source codes. See here, our program. For example, here Java program. Suppose Java program. Here this Java program, for example, test. Yes, test Java. Here this is called as source code. That English language. Our program called as source code. I think clear, right? Source code means this is source code. This is source code. Okay. Next, this is also source code. C program is source code. Okay, this called as source code here. Okay. Yes. Next, this is source code. This is source code. This is source code. Okay. Next, binary code. Yes, sir. This is binary code. This is binary code. Binary code. Zero response format. Bytecode will discuss next. In Java, I'll explain. Bytecode will discuss next. Just wait for some time. You can understand. Okay. Just wait for some time. Okay. Bytecode. About bytecode will discuss next. Wait for some time. Okay. So you can source code to bytecode by the compiler. Okay. Bytecode to binary code by the interpreter. Okay. See here Java program. Let us see Java program. D drive, test folder. In this test.java file is available. Test.java file is available. Test.java. Yes. 1 second. See here command prompt. Yes, for understanding purpose, just I'm showing at the command prompt. Actually, Java programming every day discussing with Eclipse. Yes, in Eclipse only discussing Java programming. Okay, developing all the Java applications using Eclipse. But for understanding here, just I'm using the notepad. See, D drive. Yes, D drive. Yes, now D drive test folder. So test folder. CD test. Yes, D drive. Here DER. Output test. Here test folder. Test directory. Change of directory. CD test changed. CLS. Okay. Yes, here. Now here they say test.java file. Yes, notepad, test.java. Yes, see this test.java, hello world program. Very simple program this is. Okay. Save. Exit. Now here compiling this Java program. How to compile Java C? It's a compiler. Java C means Java compiler. Yes, Java compiler. Yes, now checking for program compiled. Yes, compiled. Yes, program compiled. If no errors, generating a dot class file. .java conversion dot class file. Okay, if no errors, dot class file generated here. Okay, see this 6:28 p.m. See, 20th Jan 6:28 p.m. This time dot class file generated. The dot Java file. See 20th. So yes, 6:28 p.m. At this time test.java file is prepared. So like dot class file generated at this time, right? At this time. Okay, just now generated here. So dot class. Okay. See, I'm repeating one thing. Del start dot class. See this here don't have any dot class file. Okay, one second. Getting confusion. Yes, test.java file. Test.java file. Okay, test.java file. Java C test.java is compiling. Yes, compiled. After compilation of check it, result is not dot class file code. Previously don't have dot class. Previously don't have not dot class file generated. Dot class file generated. See 6:30 p.m. At 6:30 p.m. dot class file generated. Okay. So Java sim is Java compiler. Java compiler checking for all the errors. If no errors, then generating dot class file. Okay. See here Java compiler, Java compiler checks for all the errors, checks for all the errors, checks for all the errors. Java compiler checks for all the errors. Suppose if no errors, then generates dot class file. It generates dot class file. It's a bytecode file. Dot class is a bytecode file. Dot class file is a bytecode file. Okay. So here Java compiler check for all errors. Java compiler checks for all the errors. If no errors, it generates dot class file. It generates dot class file. Correct? Yes. Next here, see test.java, test.java, test.java. See Java program file. Test.java file given to Java C compiler. Test.java means a source code. Test.java is a source code. It's a source. It's a source code file. It's a source code. Okay, test.java, it's a source code. Okay, test.java, it's a source code. Test.java source code, the source code given to Java compiler. Java compiler checking for all the errors. If no errors here generating test.class, test.class. It's a bytecode file, it's a bytecode, it's a bytecode. Bytecode, it's a bytecode. It's a bytecode. Okay, so test.java given to Java compiler. One, just a minute. Just a minute, I'm taking some water. Just a minute. Yes. So you can test our Java source code, Java C. Yes, test our Java given to Java C compiler, compiling results, generating a dot class. It's a bytecode file. But this bytecode file taken by Java interpreter C. Now this is done. Okay, test.java converted dot class file. Java C compiler. Compiled Java C test.java generated a dot class file. Now this is executing by Java interpreter now. That's hello world. Okay, now it's a Java interpreter. So first Java compiler, now Java interpreter. Java interpreter. Okay, so this dot class file given to Java interpreter, that interpreter, given to interpreter. Okay, yes, the dot class file given to interpreter. Okay, so interpreter converting bytecode to binary code. It converts bytecode to binary code, and given to processor. Okay, see interpreter line by line. Yes, interpreter taking bytecode. Interpreter simply is this bytecode dot class file passed into interpreter. So interpreter taking bytecode and converting into binary code, line by line converting into binary code, given to processor, generating output, finally generating output. So what is happening here? Java, what is happening here? See, errors checking by the Java compiler here. If no error generates ex dot class file here. Okay, Java compile checks for all errors here. If no errors generates dot class file. Okay, yes. Next, errors checking by the compiler. Java errors checking by the compiler. Errors checking by the compiler. Errors checking by the compiler. Compile, right? Yes, runtime. Program execution. Who will execute the program? Program execution by the interpreter. Program execution by the interpreter. Yes, interpreter. Program execution by the interpreter. Okay. Yes. See, in Java errors checking by the compiler. Yes, errors checking by the compiler. In Java errors checking by the compiler. Program execution by the interpreter. So all the errors checking by the compiler. If no errors, generating a dot class file. That dot class file executed by the interpreter. That's it. Now, Java depends on what? Is it compiler or interpreter or both? Tell me, as per this explanation, what is Java? As per this explanation, what is Java? Is it compiler based or interpreter based or both here? Yes, tell me, guys. As per this explanation, what is observed here? Yes, is it compiler based or interpreter based, or is it both here? What do you understand here? What do you understand here? Yes, both, right? See here, first Java compiler, now the Java interpreter. There are two things, right? Practically showed here. First Java compiler, next what interpret, that's it here. Java depends on both compiler as well interpreter here. So Java, yes, Java depends on both compiler as well interpreter. Java depends on both compiler as well interpreter. That's it here. Java depends on both compiler as well interpreter. That's it. Now here, some question for you guys. You guys, from this explanation, some question. See here. Okay, before going to question here, yes, I'll tell you something here. Any language, runtime. Runtime is execution. Program execution. Runtime is program execution. Program running. Any language, runtime is an interpreter based. Runtime is an interpreter based. Yes, interpreter based. Okay. See, any language. Yes, any language Runtime is interpreter based. Don't have exe file. Don't have exe file, right? Don't have exe file. Don't have exe file. Don't have exe file, right? Don't have exe file. See this. This is yes, interpreter based language don't have exe file. Interpreter based language don't have exe file. See, program executing by the interpreter, there is no exe file. Program executing by the interpreter. Program execution by the interpreter, that case no interpreter here. Any language runtime is an interpreter based, no exe file. Now, let us see Java. Java language. So Java language runtime is what? Java language. Runtime is interpreter based. Java language runtime is an interpreter based. Java language runtime is an interpreter based. Okay, that point clearly mentioned here, clearly explained here. Practically, yes, executed. Java language runtime is an interpreter based. Okay, see any language runtime is interpreter based. Don't have exe files. No exe file concept if it is interpreter based. Program execution about the interpreter. Program execution about the interpreter. No exe file. In Java also, program execution by the interpreter. Yes, in Java also program execution by the interpreter. Interpreter. Now question is, yes, is there any exe file concept? Exe file concept in Java. Is there any exe file concept in Java here? Okay. Yes, is there any exe file concept in Java? Or yes, or maybe question asking like this also. Or can we create exe file in Java? Can we create exe file in Java? Yes. Anyone can answer this. From our last discussion, yes. From our last discussion, can we create exe file in Java? Yes. Is there an exe file concept in Java? Is there an exe file concept in Java? Okay. Can we create exe file in Java? See, any language runtime is interpreter with no exe file. Yes, if it is interpreter based, no exe file. Interpreter based, no exe file. Java is interpreter based. Java runtime is interpreter based. See, any language runtime is interpreter based, no exe file. Java runtime is interpreter based. So, is there an exe file? See here, in this process, see here, first program compile. See, program compile. Okay, after compilation, program executed. Okay, yes, program executed. See, in this process, have you seen any exe file here? Yes, anyone observed exe file here? Here, anyone observed exe file? Dot Java file is here. Dot class file is here. Dot class is not exe file. Dot class is not exe file. Dot class file is different. Exe file is different here. Now tell me answer. Yes, have you observed any exe file here? Anyone observed exe file in this? Yes, in this process, anyone observed exe file? No exe file. No exe file. Java don't have exe file concept. Okay, there is no concept of exe file. Okay, there is no concept of exe file here. Okay, Java. Yes, we can't create exe file. No. Can we create exe file? No. Okay, Java don't have exe file concept. Java don't have exe file concept. Java don't have exe file concept. Okay, yes, don't have exe file concept. Java don't have exe file concept. See, if exe file concept is here, that is platform dependent. Exe file is a OS dependent. Yes, that also will discuss. Exe file is a OS dependent. Java don't have exe file. Okay, any language which is exe based is OS dependent. Java is not exe based. Since Java is not exe based, is not a OS dependent. Independent of platform. How Java made us independent of platform? No exe file concept in Java. Since don't have exe file concept in Java, it's independent of platform. Yes, we'll discuss how Java made us independent of platform. That topic also will discuss very clearly. I'll explain very clearly. What is exactly exe file? What is dot class file? Okay. So why exe file is OS dependent? Exe file is OS dependent. Why? Reason we'll discuss. Okay. Yes. So Java don't have exe file concept here. Java don't have exe file. In Java, see in Java, everything is a dot class file. Everything is dot class file. Dot class file. See, dot class file is not exe file. Dot class file, yes, is not an exe file. Dot class file, yes, is not an exe file. Exe file is different. Dot class file is different here. See, exe file is a binary code file. Exe file is a binary code file. Binary code file. Exe file. Exe file is a binary code file. Yes, it's a system understandable language. System understandable. It is system understandable. System understandable language. It's a system understandable language. Exe file. Exe file is a binary code file. Exe file is a binary code file. It's a system understandable language. Okay, what is dot class? See, dot class. Dot class file is a bytecode file. So bytecode file. So dot class is a bytecode file. It's a bytecode file. Bytecode file. Okay. So dot class file is a bytecode file. Dot class file is a bytecode file. Yes, it is a JVM understandable language. It's a JVM understandable. JVM understandable language. JVM understandable language. JVM understandable language. Okay, exactly exe file dot class file differences tomorrow class. That is tomorrow class. Okay, yes. So this is about Java. Java depends on both compile as well interpreter. So the difference between interpreter and compiler here. Let us go to document here. See the documents. Interpreter and compiler, that all that 9 differences very clearly prepared. Interpreter and compiler, that 9 difference what we discussed today. All that very clearly prepared in documents. Just you can follow document here. Running notes is not necessary. Okay. See, scripting and coding. Code means that can be programming or scripting. Code you can write in scripting language or programming. This is called as code. This is code. Line by line writing is a code. Okay. Even script also. This also called as code. Python code. Python, that code can be scripting or programming. That code can be code. What are the program we are writing or script writing as code? Okay, the thing we are writing is a code. That code may be scripting or programming. This is called as scripting and programming like this. Okay, yes. Right? Yes, sir. So this is the interpreter compare differences. 1 second. Daily class material notes when will be? Yes. See, the daily class already shared. Yes, today share it to. Yes, everyone. Yes, today share it to all. Today. Yes, sir. See, how can you access your videos on daily class material? With this document already shared with you guys. This document already shared. Okay. Yes, sir. This document already shared. Yes, 1 second. But let me finish topic. After that, I will show. So interpreter and compare the differences. See, Java depends on both the compiler as well interpreter. Yes, in Java errors checking by the compiler. Yes, if no errors, then Java compiler generates dot class file, generating dot class file. Dot class file is a bytecode file. Java runtime by the interpreter. See what is happening in Java here. Okay, source code to bytecode to binary code, same what we discussed. Okay, source code to bytecode to binary code, processor then output here. Source code to bytecode by the compiler, bytecode to binary code by the interpreter. Java depends on both the compiler as well interpreter. The Java runtime is an interpreter based. Okay. See, any language runtime is an interpreter based, no exe file. Since Java runtime is interpreter based, no exe file concept in Java. No exe file concept in Java here. Can we create exe file in Java? Answer is no. Because there is no concept of exe files in Java. No concept of exe files. In Java, everything is dot class file. Dot class is not an exe file. See, exe file is a binary code file. It's a processor understandable language. Same whatever discussed, whatever things explained in the notepad, we are preparing the documentation. So class daily running notes is not necessary. Just you can follow this. Dot class file is bytecode file. It's a JVM understandable language. Same that points mentioned in the document here. Same, just you can go through this document here. You can read it. Separately running notes is not necessary. You can read this. Okay, you can read it. Yes, next topic is independent platform. Yes. See here. See, yesterday and today topic is prerequisite to understand Java features. Now you can understand Java features very clearly. How Java made us independent platform? The topic tomorrow. Difference between exe file dot class. Very interesting topic. Exe file. What is exactly exe file? What is dot class file? Why exe file is why is dependent? How Java made us independent platform? All the topic tomorrow we'll discuss. So tomorrow finishing all the features. Tomorrow features finishing here. After that we'll be going for Java installations. Tomorrow finishing all the features. Once features completed, we'll go for installation. Java installation and writing first program. Those things. Okay, 1 second. So how can you access your material and all this? Go to your Google Drive. Here there is a Google Drive. See, Google Drive. Yes, Google Drive. So go to Google Drive. See, first log in into your Gmail. Log into your Gmail. Yes, go to Drive. Go to Drive. Open Drive. Open Drive. After opening Drive here, shade with me. Yes, open shade with me. Open shade with me. Here you can see Emendra Core Java. This folder contains all your Java material. See, Core Java document. Core Java 17th December updated. This is that Eclipse. Okay, next JDK. Yes, different documents here. All this. Okay, now which one has to share? Download. Yes, download this one document. Class document. This is a class document. Core Java 17th December updated. This one you download it now. Okay. Next JDK Eclipse next class you have to download. Yes, now you download this. Right click download. Download option given here. Right click download it here. Download. Yes, and open. Read it. So this is your daily document, daily class document. Next, shade with me. Here next one more. See Core Java 5:30 p.m. Jan. Here this is for recordings. See 1 to 3 recordings are there. Last 3 classes recordings available here. Last 3 class recordings are available here. Okay, last 3 class recordings are there here. Video recording also I'll upload here. Upload files. Okay, so these are way here. See, repeating once again. First, log into your Gmail. Log into your Gmail. Yes, open Drive. So the Drive you can access. Drive. Open Drive. From the Drive here. Shade with me. Shade with me. Here, Emendra Core Java. This is for all the documents. Next, see, this is 5:30 p.m. This is for recordings. Recordings. All that recordings. From that you can access here. That's it. Okay, that's it here. Okay. Here the shade already today. Already shared. Yes, you understand? Yes, already shared here. Yes, who got the access, they can download. Okay. Yes. Yeah, you can take it, no problem. You can take the printout, no issue. No objection. You can take printouts. Printout and you can read every day. Okay. Just you can follow. Okay. Just you can take print better. If you're taking printout, then well and good. Take printout and follow it here. No problem. No issue. No objection for that. Okay. Yes. Next. Any doubts? Yes. Tomorrow topic about independent platform. Yes. Tomorrow very interesting topic. How Java made us independent platform. Okay. That Java features independent platform. Okay. In that, what is exe file? What is dot class file? These concepts will discuss. Yes. Any doubts? Still any doubts? Yeah, payments and all this. Don't worry, guys. Yes, no worry. I'm not a commercial. Pay at your convenient, no problem, no issue. Okay. Yes, no pressure on you. No pressure on you. I'm not a commercial. Okay, I'm not a commercial. Pay it ever convenient. No problem. Okay, it's not an issue. Okay, yes. Yes. Still any doubts? If no doubts, let us wind up session for today. Okay. Yeah. Thank you guys. Shall we wind up session for today? Shall we wind up session for today? 1 second. In compare, if you miss semicolon, it's a compilation error. Semicolon is a compilation error. It's a compilation error. Yes, we'll see in programming. In programming, I'll show that. Okay. Yeah. Yeah, that's all. So thank you guys. See you tomorrow.